Hello, my name is Beth Dixon, and this is a video based on Vicki Borlaug's PowerPoint presentation based on addition rule, multiplication rule, complement, and conditional probability. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoints to make this set of videos on probability. This PowerPoint is a combination of some problems on addition rule, multiplication rule, complements, and conditional probabilities. And this video may help you decide which rule or principle to apply in your problems when they're not divided into their separate types. And this is part 2 of the video series, and we're going to pick up just where we left off with part F of the series of questions based on our sample space as seen above in the table. 4 people are selected at random with replacement. Find the probability that they're all middle-aged. Well, in this problem, the first thing I see is the number 4. And I want to remember that this 4 will tell me how many times I will multiply out my fractions that I get for my probabilities. It will not be used as part of my numbers in the fractions themselves. The numbers for the fractions themselves will come from the table. The next thing I want to see is that I'm looking for all middle-aged. And I need to do it 1, 2, 3, 4. And again, instead of writing it out like Ms. Borlaug does, I generally write 4 parentheses at this stage. Now, the next thing that we want to do is look at how many middle-aged that we have to start out with. We have a total of 51 out of the grand total of 144. The next thing to notice is whether we're doing it with replacement or without. And in this case, we're doing it with replacement. That means our sample space stays constant, and therefore so does our fractions. Our sample space does not change, therefore our fractions do not change, and we have 4 fractions. And again, like I said, I tend to put these in parentheses and then fill the numbers into the parentheses. Ms. Borlaug does it with notation to represent the same thing. So that we have 51 over 144 4 times, or 51 over 144 to the 4th power. Placing that into the calculator will give us 0.0157 as our final answer for part F. Now for the last part, part G. 3 people are selected at random without replacement. Find the probability that they all own mini cars. Again, the key word here would be without replacement. The 3, though, is that number that's pesky. Students really tend to want to put that number somewhere. And for me, I start out with all mini cars as the probability, so I remember what I'm looking for. And then I draw 3 parentheses. For Miss Borlaug, she puts mini car 1, mini car 2, mini car 3, and that's how she takes care of the number 3. But that way you know where that 3 goes. I need 3 fractions. As we look at the number of mini cars, we have 61 out of 144, but we're doing this one without replacement. So every time I make a pick, I change my sample space, so my fraction must change, and it will decrease by 1. So I have 61 over 144 for the first pick, but then I have picked a mini car, and it will reduce and become 60 out of the 143 because I have 1 less in my grand total and 1 less mini car, times 59 out of 142 because again I have 1 less mini car and 1 less in my grand total. Multiplying those 3 fractions, I get 0.0738. Now we have some exercises, and I will slowly go through these. You're welcome to pause and to try these. Please do not try to do them as quickly as I go through them. That's not the speed at which I'm going through them. Here is exercise 2. And this one actually asks you to construct your own table. Question B, C, D, E, F, G, H, and that concludes our video. Thank you for watching part 2 of this video series on the many different types of probability. If you need additional help and are a Walter State student, please stop by and see me in MBSS 222. Thank you for watching.